So yesterday lecture is any doubt to you? Yesterday what we have discussed? We have discussed basically series parallel question and the variation of resistance with temperature. Qualitatively we have learned, but today I am going to explain quantitatively how to find the resistance value if we increase the temperature. Clear? For example,
Yes.
direct formula I am not giving you, but I am telling simply. For example, if the temperature is initially T, if I increase the temperature by dT amount, clear? Then at temperature T, resistance is R naught. If we increase the temperature dT, then resistance becomes R naught plus dr. Clear?
Yes, sir.
This change in resistance dr is directly proportional to the dT. dT means what? dT means change in temperature. Clear?
Yes, sir.
And it is directly proportional to the initial value of resistance. More the initial value, more is the change in resistance. Lesser the initial value, lesser is the change in resistance. What is dr? dr is the change in resistance. If I combine all the factor, then I will get what? dr is directly proportional to R naught dt. Clear? And if I remove this proportionality sign, I will get one constant. That constant is alpha. Clear? This alpha is what? This alpha is coefficient of thermal expansion. You can write what is alpha? Alpha is coefficient of thermal expansion, or you can say thermal resistance, because we are learning resistance, so it is coefficient of thermal resistance. Clear? Any doubt?
Yeah. No doubt, sir.
Then this, what is dr? What is dr? This dr is what? If I write here, change in resistance. What is this? It is a change in resistance. Change in resistance. And what is dt? dt is a change in temperature. Change in temperature. And what is alpha? Alpha is the coefficient of thermal expansion. Clear? Now listen me carefully. I am not going to do the integration because you don't know integration. You are in class 10th. You don't know what is integration. We will do integration. After integration, we will get this result. RF final resistance is equal to initial resistance R naught. This is important result. 1 plus alpha delta T. Here, this is the, what is RF? RF is the final resistance. Final resistance. R naught is the initial resistance. There. And what is delta T? Delta T is the change in temperature. Understood? This
Yes,
relation
sir.
you will apply only when alpha is constant. When it is constant. In most of the question at your level, alpha is constant. Understood? Any doubt?
No doubt, sir.
Clear? It is found. Whatever I am writing, this all are, from where I am writing this, dr is directly proportional to dt. This change in resistance is directly proportional to the change in temperature. From where I got this? It is experimentally. All whatever I am writing, it is from experiment. Clear? All are experimental result.
Yes, sir.
We have found this. That's why I am teaching this. Clear? This RF,
Yes, sir.
the alpha value. This alpha value in case of metals, if you want to write, you can write. In case of, just a minute. Wait. This value of alpha, which I have written, this alpha for conductors, for metals, or we can say metals, conductors. For conductors, this alpha value is positive. If alpha is positive, then please tell me, if I increase the temperature, Rf is equal to Rho 1 plus alpha delta T. You please tell me, if alpha is positive, then if you increase the temperature, then delta T is also positive. This is positive and it is already positive. Then Rf will increase with increase in temperature. If you increase the temperature, then final resistance always increase. That's what you have learned. On increasing the temperature on increasing the temperature of the metals, its resistance increase with increase in temperature. This is what you have learned. Clear? Any doubt?
Yes.
For
Not
semiconductors,
outside.
for semiconductors, this coefficient of thermal resistance, semiconductor for semiconductors, this value of alpha is negative. That is why Rf, on increasing the temperature, resistance of semiconductor decrease. That is what you have learned. If alpha is negative and delta T is positive, and if you increase the temperature, then RF value means it is the value of resistance at final temperature, or we can say that final resistance. Clear? Its value increases on increasing the temperature for semiconductor, this RF value decreases because its alpha is negative. Yesterday we have learned qualitatively. Today we will understand how to calculate this value. Understood? For alloys, for alloys, for alloys, alloys, this alpha is approximately 0. Approximately or tending to 0. Very, very small. Clear? Now write one question. Write one question. The resistance of a, write one question.
Sir, can you please show the previous slide for a second?
Yes. Please write. Okay. Now moving to the next. Write down the question. The resistance of a, with question you will understand. Write down the resistance of a heating element at room temperature how much? 27 degrees Celsius. The stop is 100 ohm. The stop at what temperature? Write down the question. At what temperature its resistance will be 117 ohm. If the value of alpha, if alpha is 1.7 multiplied 10 to the power minus 4 degree Celsius inverse. Option I am giving. Apply the formula, give me the answer. Option I am giving 967 degrees Celsius. Option B 1030 degrees Celsius. Option C 976 degrees Celsius. Option D 1027 degrees Celsius. What is the answer? Please try this question and I will also help you. Please look at the question first. Apply the formula RF is equal to RO 1 plus alpha delta T. Clear? Now you please tell me at room temperature how much? 27 degrees Celsius. Convert in Kelvin to 73.15. Let us suppose you will this temperature is in Kelvin. How much resistance here? RO. Clear? Initial. At what temperature they are asking? At what temperature its resistance will be how much? 117. They're asking like this. So it's very simple. Alpha is given. Calculation only. Alpha is how much? 1.7. Delta T. So delta T is how much? Final temperature minus initial temperature. Final minus initial. Initial is T naught. Clear?
Yes, sir.
If you want the answer in Kelvin, you should put the value of T naught in Kelvin. If you want the answer in Celsius, no need to put in Kelvin. Clear? Answer will be in degree
Yes.
Celsius. And they have asked. And you can write it like this. It will be what? 117 minus 100 equal to 100 to 1.7 multiply 10 to the power minus 4 multiply delta T will be what? T minus 27. T will be what? T minus 27 is how much? 117 minus 100 how much? 17. 17 by 100 to 1.7 into 10 to the power minus 4. Once you solve, you will get the answer 1027 degrees Celsius. You can check also. 17 cancel. 10 to the power minus 4. It will be 1010 cancel. How much? 1000 plus 27. It is 1027 degrees Celsius. Clear? Any doubt?
Yes, sir.
Right, next question. One more question I will ask.
No, sir.
Right, one more question. Question 2. The resistance of a platinum wire the resistance of a platinum wire is 5 ohm at ice point and 5.5 ohm at steam point. To stop Find the temperature. Find the find the temperature at which the resistance of the wire at which the resistance of the wire is 5.8 ohm. 5.8 ohm. Okay. So option I'm giving, first option 120 degrees Celsius. Option B 160 degrees Celsius. Option C 200 degrees Celsius. Option D 240 degrees Celsius. Solve this. It's an easy question. Simply ice point means, what is the ice point? Ice point means how much temperature? 0 degrees Celsius. This is what I already teach to Sai Charan. Okay, steam point means 100 degrees Celsius. Temperature is 100 degrees Celsius. What is the answer? Simply tell me.
Sir, why give the steam point, sir? It's not necessary, right, sir?
How much?
No, sir, I have a doubt. Why did they give that steam point? It's
They
not
will
necessary, right?
listen. They will give ice point, steam point. Nobody knows. Clear? They know 100 degrees Celsius, 0 degrees Celsius. So at ice point means at 0 degrees Celsius, how much resistance? 5 ohm. At 0 degrees Celsius, how much resistance? 5 ohm. And at steam point, 100 degrees Celsius, how much resistance? 5.5. They are asking at what temperature? At what temperature? Resistance is 5.8 ohm. This is the question. Did they
Sir,
mention
did they give
alpha?
the did
Alpha is not.
they give that
Alpha
information
is,
to confuse the like,
yeah, to make you confused, because IIT question they will confuse you. Okay, they will not give you the direct answer. Okay, they will not ask you direct question also. So first of all, we will go from 0 to 100. Clear? Always we will take the reference. Reference is 0 degrees Celsius. Clear? From there, I will increase the temperature by 100 degrees Celsius. So apply the formula first. Resistance at 100 degrees Celsius equal to resistance at 0 degrees Celsius 1 plus alpha delta T. How much? 100 minus 0. How much resistance at 100 degrees Celsius? 5.5. 0, 5, 1 plus 100 alpha. So it will be 5.5 by 5 minus 1 equal to 100 alpha. What is the value of alpha? Tell me. Alpha will be 0.5 upon 5 to 100. It will be positive 10 to the power minus 3. Unit whatever it is, let us, we are not worry. Alpha value we got. We got the alpha. Now again apply the same
yes, sir.
formula. Again apply the same formula from 0 to T. R resistance at this temperature T. Resistance at 0 degrees Celsius. Always we will take from reference. Okay. 0. Reference from the value of temperature from where we start. We are giving heating. Okay. We have started heating from 0 degrees Celsius. So 0 degrees Celsius is our reference point. Clear? 0 to
Yes, sir.
100, first we will apply the formula, then 0 to T. Then only you will get the correct answer. 1 plus alpha T minus 0, it is T. Then RT, how much? 5.8. Resistance at 0 degrees Celsius, 5. 1 plus alpha, alpha is 10 to the power minus 3 to T. Solve this, it will be 5.8 by 5 minus 1 equal to 10 to the power minus 3 will be how much? 5.8 minus 5 will be how much? 0.8.
0.8.
How? 0.8 by 10 to the power minus 3. Approx, I think how much? What is the temperature? Tell me. Here 5 also, na? We forget 5. How much?
Sir, did you subtract the ones?
Yes, I have subtracted. 5.8 minus 5 it is 0.8. 8 into 100 by 5. 5 to the 160. Option 160. Check.
Sir, 1 minute, sir. Yes, sir.
Clear? Any doubt?
No, sir.
Okay, right. One more question. Write this question. Find the relation between find the relation between rho 1 alpha 1. What is rho 1? Resistivity. Alpha 1 comma rho 2 and alpha 2 such that resistance of the combination such that the resistance of the combination is independent of temperature. Find the relation between rho 1 alpha 1 rho 2 and alpha 2. I will draw the diagram also such that the resistance of the combination is independent of the temperature. You please tell me rho 1 alpha 1 it is for one material. Rho 2 is a property of material, different material. Resistance of the combination is one material. You just combine two material. Here, this is material 1. This is material 2. What they are saying? They are saying what is the resistivity of this? Rho 1, temperature, coefficient of thermal resistance, alpha 1. Similarly, here it is, this wire is having rho 2, alpha 2. What they are saying? The resistance of the combination, clear, is independent of the temperature. Independent of the temperature means initially. You please tell me. Initially, what is the resistance and combination? For example, this wire is having resistance R1. Clear? This wire is having resistance R2. So initial, what is the resistance? Initially, R1 plus R2. Any doubt?
No, sir.
Then what is the final resistance? What is the final resistance? Initial is R1. Initial is R1, R2. When you combine R1 plus R2. Clear?
Yes, sir.
Now delta T. Delta T, what they are saying? The resistance of the combination is independent of temperature. For example, initially both are at equal temperature. Clear? Both are at equal temperature. Once you increase the temperature, clear? Once you increase the temperature, then they are saying their combination resistance is independent of the temperature. Clear?
Sir, then
Individual,
RF
yes.
R1 plus R2, sir.
RF initial resistance combination equal to final. R1 final plus R2 final. Clear?
Sir, I have a doubt.
Yes.
Then RF will also be R1 plus R2.
R1 final plus R2 final. Final resistance, na? When you increase the temperature, it will be equal. Initial equal to final. Independent of temperature means whatever. If you raise the temperature of both the wires, clear? They're because alpha 1 and alpha 2. They have different R1 and R2. Clear? But their combination, the combination initial combination resistance is equal to final combination resistance, because they have said, they already mentioned, resistance of the combination is independent of the temperature. Combination resistance will be independent of temperature. Individual they are not saying. Clear? So it is initial combination, okay, is equal to final combination. Independent of temperature means resistance value can only be changed by the temperature. But they have already mentioned it is independent of temperature. Independent of temperature means there is no effect of temperature on the equivalent resistance value. I am not saying like there is a no effect on the individual resistance, but there is no effect on the equivalent resistance value. So initially, what is the equivalent of these two? These are in series, R1 plus R2. Once you increase the temperature, then final resistance will be RF. Final resistance will be what? R1 how much? First wire, it will be initial resistance 1 plus alpha 1 delta T plus R2 1 plus alpha 2 delta T. Then it will be what? RF will be how much? Combination how much? R1 plus R2 plus delta T common R1 alpha 1 plus R2 alpha 2. Calculation only. Now according to question, this RF is what? It is the combination resistance. One after increasing of temperature, how much? Delta T. Then what is the equivalent resistance? R1 1 plus alpha 1 delta T, R2 1 plus alpha 2 delta T. Tell me any doubt up to this point?
No doubt, sir.
Any doubt? Still they are asking the relation between alpha 1, rho 1, clear? So I think now onwards it is very easy. Clear?
Yes,
Length
sir.
also equal. Okay, they have mentioned the length of the wire is also equal. Length also equal. So you please tell me initial is equal to final. So it will be R1 plus R2 plus delta T, R1 alpha 1 plus R2 alpha 2. It is equal to initial. Initial is how much? R1 plus R2. Cancel out. Clear?
Yes, sir.
Then it will be what? Delta T R1. R1, what is that? Alpha 1. Is it so? Check.
Yes, sir.
R2
Yes, sir.
delta T. So I can say, can I say like that? R1. This can't be 0. Okay, delta T is not equal to 0. But R1 alpha 2 plus R2 alpha 2 will be 0. Then what is R1? R is rho L by A. Rho 1 L by A. A also constant. We will take area of cross section also constant. R2 will be rho 2 L by A alpha 2. So this L by A common, we will take it to the left side. We will what? Rho 1 alpha 1 plus rho 2 alpha 2. See the relation. Equal to 0. It's little bit tough. So Mike, what I am saying, if you take two wires having different material, equal length and equal area of cross section, equal length and equal area of cross section, clear? This is rho 1 alpha 1, this is rho 2 alpha 2. And for example, initial resistance of this will be R1, here R2. Let us suppose it is whatever else. Initial combination resistance will be R1 plus R2. And initially both are at the same temperature. Let us suppose room temperature, 27 degrees Celsius, 27 degrees Celsius. So at 27 degrees Celsius, what is the value of resistance of this wire? R1. What is the value of resistance of this wire? R2. So you just combine the combination resistance, R1 plus R2. Now you provide some heating. You provide some heating to both the wires, equal rate. Equal rate means the temperature increase of both the wires equally. Delta T equal, okay? Then final combination will be, it will be final resistance how much? If you increase the temperature, if you provide heating, then it has different alpha 1, it has different alpha 2, then final value will be different now. That is what? If you combine R1 will not be R1, it will be R1F plus R2 final. Then R1 final, when you increase the temperature, how much? Initial plus 1 plus alpha delta T. R2F, R2, 1 plus alpha delta. And RF is equal to RI. This is what RF. RF is a combination resistance, final combination of resistance. Okay. Then they are saying RI is equal to RF. RI is equal to RF. When you put the value, the R1 plus R2 cancel out. Finally, you will get the rho 1, this relation, rho 1 alpha 1 plus rho 2 alpha 2. Direct relation, you must remember this. Okay. Any doubt?
Sir, you said that delta T cannot be 0, sir, but how can it be explained, sir?
Delta T, I kept
that
the constant. I increase, I provide equal rate of heating. Means initially it is 27. This wire is also at 27. After increasing the temperature, its temperature become T. It is also become T. Then delta T in first of the wire it will be T minus 27. Second wire also T minus 27. So delta T is not equal to 0. So I can't write here delta T at which I have written. It is should be equal to product should be 0. Clear? But this equation who will satisfy? Only this can be 0. Only this can be 0. R1 alpha 1 plus R2 alpha 2 can be 0. Because product of this will be 0. Then this is 0 only because of this term. Delta T is not equal to 0. That is why I am not equating this. Okay. So simply 0
Yes,
by
sir.
R1 alpha 1 plus R2 alpha 2 equal to 0 by delta T. Delta T is not 0. 0 by something number is 0 only. How I write
Yes,
it?
sir, understood.
R1 alpha 1, if you want like R2 alpha 2, it will be what? 0 by delta T. Delta T is not 0, it is something specific value, some specific constant. Then R1 alpha 1 plus R2 alpha 2 equal to 0. Length is constant, area is constant. So relation is rho 1 alpha 1 plus rho 2 alpha 2, it is 0. This is IIT question, okay? They have asked in IIT. So I will share one more link. Please join there. I will today we will finish this. Okay, resistance part.
Yeah.
Some more question. Okay, please join from the next week. It is stone bridge. It is stone. This is a concept only. Okay, in your syllabus it is concept only. It is stone bridge. For example, Wheatstone bridge is a network, okay? Bridge-like network. Have you seen bridge?
Yes, sir.
So it is in the shape, okay? One register is here, one register is here, one register is here, one register is here, and this is cell. Here we have connected a cell or battery. And there is one register in the diagonal, maybe galvanometer or battery voltage V. For example, this is R1. Wait, this is R1, this is R2, this is R3, this is R4. Clear? And this is R5. So what is Wheatstone bridge? Wheatstone bridge is simply if the ratio of adjacent arms, these are arms. What are these? These are arms or branches. If the ratio of adjacent arms R1 by R2 is equal to R3 by R2, R3 by R2, then let us suppose this is E, this is F, this is Q, and this is R. So when R1 by R2 is equal to R3 by R4, then potential at E, or we can say that potential at E is equal to the potential at F. Means what? If there is a voltage of 40 volt, here also 40 volt. You please tell me. Now if the battery is giving a current I, this is a junction here, current will divide I1, this is I2. When this current I1 is going, will you see any current in this branch? No. There is no current in the EF branch. Current I1 will go like this. Why? Because when this is balancing a balanced Wheatstone bridge condition. This is a balanced Wheatstone bridge condition. Clear? Now you please tell me, if there is R1 by R2 is equal to R3 by R4, then potential at E is equal to the potential at F. If the potential is same here and here at F and E, will you see any current here? No. Why? In order to flow a current, what is the basic need? Potential difference. If there is no potential difference, there is no flow of current. Clear?
Yes, sir.
Then there is no current from this branch. You can say this E and F are at same potential, so there is no current. No current from this. No current. If there is no current from a resistor, then this is waste. This is waste. There is no use of it. Then how will you draw a circuit again? Simply you will remove this resistor. If there is no current, then it is waste. We will not see this. We will draw again like this. The cell. Understood?
Sir, then what is the use of Wheatstone bridge, sir?
R1, R2, what?
And what is the use of balanced Wheatstone bridge, sir?
What is the use of balanced Wheatstone bridge? Very too much use. For example, in the experiment, you are performing a lab, 12th class you will perform. If you know R1, R2 and R3, If you don't know R4, unknown resistor, then with the help of Wheatstone bridge, for example, if you connect here galvanometer, this is galvanometer. You know galvanometer?
Yes, sir.
If there is no deflection, if what resistance, what is the value of R4 I should connect here so that there is no deflection in the galvanometer. No deflection in the galvanometer means galvanometer. What is the use of galvanometer? It is used to detect the presence of current. So basically, this balancing condition help us to find the unknown resistor. What is the value of this unknown resistor I should fix so that this bridge can be balanced. If bridge is balanced, you please look at here. You are supplying some current I from the cell. It is going to divide I1 and I2. No current is passing through this load. Clear? Understood?
Yes, sir.
Any doubt?
No doubt, sir.
So this is Wheatstone bridge. Balancing condition. Clear? Look at this. This is one. This is what? This is key. This is galvanometer. This is rheostat. And what is this? RQS. This is registers. How to use it? You learn class 12. Clear?
Yes, sir.
Any doubt?
No doubt, sir.
Look at this. Relay. Relay. These are diodes. Here. Here it is basically used for Wheatstone bridge in electronic industry. We are mainly used for in your mobiles. It's a Wheatstone bridge. There is no current in this middle diagonal bulb. Can you check? Why? Because potential difference is 0. Here potential is 40 volt. Here also 40 volt. I have explained that there will be no current through the diagonal. It is balanced Wheatstone bridge. Clear? Understood?
Yes, sir. Understood.
Okay. Write one question. How to apply this? Solve this question. A 4 to this is 16. Eight. Now you need to find the equivalent. Question is find the equivalent resistance between C and D. Clear? Now my question is, they are asking find the equivalent resistance between C and D. Then connect a battery. Connect a battery in between C and D or cell. First step. The battery will supply a current, I current. Then it will take I current. You please tell me, can you check Wheatstone bridge? What is the ratio of this? 16 ratio 4. This is R1, R2, this is R3, this is R4. Look at check the Wheatstone bridge condition R1 by R2 how much? 16 by 4, 4 by 1, R3 by R4 how much? 8 by 4 by 1. Ratio is same, okay? R1, the balanced Wheatstone condition is fulfilled. R1 by R2 is equal to R3 by R4. It means what? There is no current passes through this resistor. Whatever it is 16 ohm. For example, there is no current passes through this. Clear? Then again you will draw a circuit. See? See. Can you tell me the equivalent resistance now?
Sir,
We
is it
see
see,
this is
1
4,
minute, sir.
16, 2, 8. This 4 and 16 are in series. 4 and 16 are in series. They are asking what is the equivalent resistance between C and D. Now look at this 4 and 6. This 4 and 6, 16 are in series. It will be how much? C, D. 20 and 8 on 2, 10. Then in between C and D, we are connected a cell or battery. Then 20 and 10 are in parallel. Clear? 20 and 10 are in parallel. What is the equivalent? 1 upon Rp is equal to 1 upon 20 plus 1 upon 10. It will be what? Rp will be what? 20 into 10 by 20 plus 10. It will be how much? 20 into
Sir,
10
my
by
screen,
30.
please explain, sir.
20 by
My
3.
screen.
Wait. 20 by 3. So equivalent resistance will be how much in between C and D? C and D. How much? 20 by 3. This R equivalent. Again, I will explain. First, we have applied the balance Wheatstone bridge condition. They are asking find the equivalent resistance between C and D. Then I just connect a battery or cell. Next, I have seen current is going from the battery. Here I1 current will flow. Here I2. I1 here, I1 here also, I1 here. And current is same in these two resistors. They are in series 4 and 16. So simply I just connect, final the equivalent. Similarly, this I2 is passing through this. How much? Here I2, same current. 2 and 8 are in series. 8 to 10, 16, 4, 20. Then this 20 and 10 are in parallel. Clear? Because you can check 1, 1, 2, 2. 1 is connected at C, 1 is connected at C. 2 is connected at D, 2 is connected at D. So both are in parallel. So I just find the equivalent in parallel, and in between C and D, I just connect. So in between C and D, what is the equivalent resistance? 20 by 3. Understood? Symmetry, one topic is symmetry of circuits. That is not a part of your syllabus. In class 12, you will learn. So today, resistance part. Maximum to maximum finish. Clear? Up to more than IIT, actually I teach. Understood? Clear? Tomorrow lecture, what I will do, I will start Kirchhoff's law. Tomorrow, maybe tomorrow or day after tomorrow, because Sai Charan classes I will take. Actually, I am taking very less classes for Sai Charan. Reason is because my main objective is in coming days, working days, in days, I want to complete your syllabus first, because Lot of
Yes,
leaves we have taken now when you are during exam. So I want to complete the IIT syllabus. Otherwise, things will be missed. It will be problematic for us also. I don't want
yes,
to left anything. Okay. Sai Charan, I will take tomorrow, maybe tomorrow or day after tomorrow, or Sunday. I will take long class. No need to worry. For him, no need to worry. Maybe, but I want to take your class first. Sunday, I will take 3 hour also class for 2 hour. I will take class for it. No worry. But my main objective is to take your class. Clear? Is it okay? Once your syllabus is on track, I think one chapter is left, but this current electricity chapter is very important. Once this is finished, then I will definitely Sunday or before Sunday also I will take Sai Charan classes. Maybe tomorrow I will take. Okay, no need to worry. Sai Charan classes I will take. Ask him to revise. Okay. Okay, Bhalamika. I will stop.
yes, sir.
You can hear me. That is okay. No need to worry. Okay. Any doubt till now?
Yes, sir. No doubt, sir.
Work hard like this. Keep away. Keep moving ahead. There we smile
Yeah.
like that. Okay. Bye bye. Take care.
Thank you, sir. Thank you, sir.